Okay, Bismillah ar-Rahman ar-Rahim. This problem is the last in that paper back. Bacteria is growing according to the function. So this is the amount of bacteria in thousands, and this is the time t in hours. Okay. Determine the second derivative. So you need to find out the first derivative. We did this first derivative in the previous video. So let's open it up and put the function 250 times 1 is 250, 250 times 12 at 3000. So I'm going to open this and this times this, 3000 t over t square plus 36. Okay. So we want to do it like the same way we do it before, and that's the technique that we always used to do. Let's just take the function, that this is the function that we are going to be doing the derivative of. Let's look at it. You could do it this way or the other way. That's completely up to you. Okay, now we want to find out the derivative of this function. The derivative of this function is like this. First of all, we have to square the bottom. Square this. Okay, and then you're going to multiply this one, the bottom, with the derivative of the top. So the bottom times the derivative of the top is 1. Derivative of t is 1. That's the first term. And then minus the top minus the derivative of the bottom. The derivative of this one, it's 2t. Derivative of 36 is 0. So now you're going to open up the terms. It's t squared plus 36 minus, this is 2t squared minus 2t squared over t squared plus 36 squared. So you could summarize it like that. T squared, it's minus t squared plus 36 over t squared plus 36 squared. Okay. Now you're going to find out the derivative of n dash t. Now, what did we do? We find the derivative of this function. So, as you're going to go for it, the derivative of this one is 0. The derivative of the second one is 3000 times this term. So 3000 times the derivative of that term minus t squared plus 36 over t squared plus 36 squared. Okay, that's the derivative. And now we need to find the second derivative. Okay? We will do the same thing. We will do the same method. The second derivative, we're going to square the bottom. It's going to be t squared plus 36 square, that's fourth. And now we're going to put the bottom here, t squared plus 36 squared times the derivative of the top. And we have to make sure that there's a 3000 here. So we're going to leave the 3000 outside the term. So we could, not going to forget this. That's multiplied by the whole thing. So the derivative of the top, it is minus 2t. Don't worry about 36. 36 is 0. Okay, and now this is minus. What is the derivative of the bottom? Now you're going to do this down to t squared plus 36, 2 minus 1, times 2t. That is the derivative of this term, the bottom, times minus t squared plus 36, top. Just put it as is. This is the how to find the derivative of the term if you have something up and something down. Okay, so now we have to factor. Which one we should factor? We should take the t squared. Take the 3000 first. I'll take t squared plus 36. That's this term. Okay, and then t squared plus 36 times minus 2t, and then minus 2t minus t squared plus 36 t squared plus 36 to the 4. So this cancel with this. This is going to be third. So I'm going to erase it now. I'm going to erase this. So this is going to be to the third. So now, could we do more factoring? Let me take the t out. So we could take the t out and see n dash t so you could do it like that, 3000. If you take minus 2t t squared plus 36, and you take minus 2t from the other side, so it is 2 times minus t squared plus 36. The whole thing over t squared plus 36 cube. Could you do any more simplification? We should open it up and see if that helps. See, 3000 minus 2t t squared plus 36 minus plus 2t squared minus 2 times 36. Okay, 2 times 36. This is minus 2. So 36 times 2.
72.
Okay, so minus 72. Okay, and this is divided by t squared plus 36 cube. So you can see this one. This is going to be 3t squared. And 36 minus 72. Well, you could leave it like that.
36.
So this is going to be minus 2t. So it is minus 2 times 3000, 6000 t squared. This is 3t squared. 36 minus 72 is minus 36 over t squared. This is like more simplification if you want to. That's the second derivative. Now let's determine and interpret n dash 4, n double dash 4 in the context of the situation. So we're going to put n dash 4 inside it and see what's going to happen. So when you put t minus 6,000 4 3 times 4 square minus 36 over 4 square plus 36 cube. When you put it like that, you will get a minus, because there's a minus at the end. So at time, so this is 3,000 times minus 96, and that's going to give you minus 2.048. So at time equal to 4 hours, the bacterial population, and this is not going to be like that. The bacterial population, initially for the first term, when you do the n dash at T4, the bacterial population is increasing, but at decreasing rate is decreasing. This negative second derivative, it means that the growth rate is slowing down. So the negative number here, that the growth rate is slow down at t equal to 4 hours. Okay. So now the point is, for the last one, at what time is the population growing the fastest? At what time the growth is the slowest? Of course, there's two things that you might get out of this. Okay. What is population grows at fast? Population growth is fastest when the n dash t is at max. Okay, and how could we find this n dash t at max? We need to find the second derivative. So if you want to find out the fastest, you need to find out the second derivative and make it equal to 0 to find the time. And when the second derivative, it means that it's equal to 0, it's going to go from negative to positive, or from positive to negative. This is population is at fast. So we will do the n dash t. Let's see, we'll have it as according to the final answer we got previously, times t times minus t squared over t squared plus 36 cubed. Okay, now we set the numerator of this expression to 0 to find the critical point. So we're going to set this, because we can't set the bottom equal to 0. We're going to set the top. So it's either t is equal to 0 or minus 6t squared plus 72 equal to 0. So when you do this, t is equal square root of 12, which is 3.46, which means at time 3.46, the growth is at fastest. Okay. So the fastest growth happened when time is equal to 3.46. Now, this when the slope of the growth is the steepest. Which means that the population is increasing at a higher rate, which is a turning point from negative to plus, or plus to negative. Now, let's look at the second chance, or the second problem. When is the time when it's at slowest? When the growth is the slowest? Well, there are two meaningful interpretations here. We find out that at time equal to 0, the population just started growing, and the initial growth is 0. So the initial growth zero. The growth is very slow at the beginning, of course. Anywhere, the growth is very slow. If you have a baby, and this baby will grow slowly initially. Same thing for bacteria. At time goes to infinity, then the first derivative goes to 0. When you go that the first derivative, you can see at time equal to 0, you could see it from, or at time goes to, when this is very big, you can see that everything goes to 0 as well. So this is, by definition, time goes to infinity, n dash t is going to 0. So the growth slow down again. So initially the growth is slowing down, and finally at time goes to infinity, the growth slow down again. Okay? Therefore, so the fastest growth, we found it at time equal 3.46 hours. The slowest growth happened at two terms. When time is equal to 0, at the very beginning, and when it is a very, very large time, when time is equal to infinity. Okay? So these are the things for this example.